An SR or set reset NOR gate latch is similar to the NAND gate latch, but behaves entirely different. So you do have to memorize how the NOR gate latch operates versus the NAND gate latch. In the NOR gate latch, these are called active high, which means they need to be the S and R are active high, which means that they need to be pressed into high in order to be active, in order to trigger this latch happening. So when we say S equals 1, then you get Q equals 1. So to set, we need to trigger or make or press, we need to make S into a 1, and that will set the latch. And just with any latch, setting the latch means Q equals 1. So here, if they're sitting at 0, I want to set the latch. It means that I need to purposefully go from a 0 to a 1 in this signal S, which sets a latch. Now Q equals 1, and we're all happy. Now, if I want to reset the latch, then I need to go R equals 1 in order for Q to equal 0. And that's how I would reset the latch. So if I turn R into 1, up here at 1, then I reset the latch and Q goes to 0. Here, if I set them both to the value of 1, then I'm just being silly. That will never happen. It'll make things go really weird and unpredictable. However, if they are both sitting down at 0, then nobody chose to set the latch. Nobody chose to reset the latch. It's just going to keep the value it has. And a real world example of that is when is in that alarm system where it's going to get set, and then it's going to hold that position until a change happens. It's going to keep ringing that alarm until somebody resets it and drives R to 0 to reset it. So I won't painfully go through every case in this truth table, but if you want to, you can draw this diagram and you can painfully sit through every case and make sure that the output indeed does go to 1 here and 0 here, questionable here, and no change here, because that's how a NOR gate flip-flop works. In the NOR gate, I find it kind of interesting, a little bit more intuitive, because if I say I want to set something, I would intuitively say to set it, I want to press set into the value 1 instead of into the value 0. So I like the NOR gate better than the NAND gate. So that's how that one works. And we're going to do an example in class where we put in a waveform where here we want to set, and here we want to reset. And down at the bottom here, we're going to draw what's happening to Q as it gets set and reset. And we will do that in synchronous class.